Hello guys, let us see questions from previous year GATE papers related to amplitude modulation in communication systems. So you can refer theory videos for the concepts and the derivations. So this is part number 5, like we have already 4-5 videos available with you for so many questions. The question is, this is a very important question that was asked in previous year GATE, that is given as the amplitude modulated signal is given by S of t is equal to 20 plus 4 cos 8 pi into 10 to the power 40 plus 8 cos pi into 10 to the power 5t into cos omega ct or 2 pi f ct, right? So we have to actually find out what is the total power in amplitude modulated signal, but we will try to find out other parameters as well. What is my total modulation index, bandwidth, as well as efficiency of the AM signal. Okay, so what is the form of this particular equation is, we can write it down something like this. AC will take out common, plus 1 plus mu1 cos 2 pi fm1 into t plus mu2 cos 2 pi fm2 into t, okay, into cos 2 pi fct. So this is the form that we will take up. Okay, so what shall we do? The first thing, 20 we will take out common, so we'll have 1 plus mu1 mu2 form. Okay, so I have done it for you. Here 20 I have to common, so it will become 1 plus 4 by 20 and plus 8 by 20. Alright, so this is how you are going to get, this is mu1. So what will be the AC? AC is 20, then mu1 is 4 by 20, that is if you cut it you are going to get 2 and this is 10, so 0.2. Okay, and fm1 is this frequency, so that is 2 pi fm1 into t. So fm1 is how much? 2 pi you take common, so 4 into 10 to the power 4, that is 40 kilohertz. Okay, similarly mu2 is 8 by 20, 8 by 20, that will be how much? If you cut it 4 8 10, so that is 0.4. and fm2 is same way, 2 pi fm2t, so 2 pi you take common, so it will become only 5, so 10 to the power 5 by 2, right? So that will become 50 kilohertz. So you have first message signal frequency, second message signal frequency, your first amplitude modulation modulation index, and second amplitude modulation index. Okay, what do we need? We need total modulation index, that is very simple, mu1 square plus mu2 square, that is going to be 0.04 plus 0.16. Okay, so this is going to come up as 0.20, which will give you a square. 0.20 is 0.447. So this is your total modulation index. Okay, next we have to find out what is the total power available in the amplitude modulation. So total power available will be how much? PC into 1 plus mu square by 2, that is mu total we will take, because we have to identify the total modulation index power. So PC is how much? PC is very simple, AC square by 2, so that will come up as how much? 20 square by 2, that is 400 by 2, that is 200. Okay, so 200 into 1 plus mu t square is how much? 0.2 ka, like 0.2, right? A square root of 0.2 was mu t, so mu t square is 0.2, so 0.2 divided by 2, that is 1.1. so 1.1 multiplied by 200 is 220 watt. So 220 watt is the total power of the amplitude modulation signal. So this is a very simple question, but a conceptual question. Okay, you have to just take out this AC outside based on this particular concept. Okay, now proceeding to next, what is my bandwidth and efficiency? So bandwidth will be calculated based on the maximum frequency that is available in the amplitude modulation. So maximum frequency will be how much? Either it can be fc plus fm1 or fc plus fm2. So whichever is maximum, that will be this 50. So according to maximum frequency we will calculate 50 into 2, that is 100 kilowatts. How it is calculated, I'll just tell you again. Let's say this is fc, so this will be, let's say, fc plus fm1, and this will be fc plus fm2. So similarly fc minus fm1 and fc minus fm2. So the maximum bandwidth, that is decided by this fc plus fm2 minus FC minus FM2. Okay, so this is your bandwidth. So that is going to come up as how much? 2 FM2. So it is nothing but 2 into maximum signal frequency. So maximum signal frequency was 50, not 40. Okay, what is the efficiency that is being asked? So efficiency formula we already know, P sideband by P total. So P sideband by P total comes to mu square by 2 plus mu square, and here mu we will utilize the total modulus index. So 0.2 divided by 2.2, that is 1.1 by 11, that is 9.09%. Okay, so that's all. This is very simple, right? Let us take another question. So the another question is, we have an amplitude modulated signal. Okay, the carrier signal current is given. Okay, so the carrier signal current is 5 ampere and modulation index is 0.5. What is the total AM signal current in the amplitude modulation? So what will happen? You guys already know that IC is 5 ampere and mu is 0.5, and the relation was what? IT square was IC square into 1 plus mu square by 2. Okay, so with this you can very easily find out what is your total AM signal current. That will be IC square, that is 25 into 1 plus 0.25 by 2. So I have done it for you. So it will become 0.25 by 2, that is going to be coming up as 25 into 1 plus 0.25 by 2, that is 28.125. This is your total amplitude signal current ka square, right? So to find out the current, total current, square root of this 28.125, that is 5.303. So this is the answer. Suppose what is the current when there is no modulation index is 0? It means whatever the carrier current is there, the same current will be there in your total amplitude modulated signal as well. So you can see mu will be 0, it becomes IT is equal to IC, that is 5 ampere itself. Okay, let us take another question that was asked in previous year GATE. The question is, in an amplitude modulated signal, the total current is 10 ampere. Okay, so this is very important question that was asked. Okay, the total current is given 10 ampere with modulation index 0.4. So my IT was 10 ampere with mu1 was 0.4. Okay, what will be the total current of AM signal with modulation index 0.8? So basically IT2 we have to find out for modulation index 0.8. Okay, it is not consecutive modulations, it is separate modulations. Okay, once it was there, then we want to find out what would be the total current with this modulation index. So what do we need? If we know what is the relation that was there, PT in the total power was PC into 1 plus mu square by 2, and from here we had find out what was the relation with current. So IT square was IC square into 1 plus mu square by 2, right? So if we have this IC current, if we have this carrier current, then we will be able to find out what is my total current. So we have mu, we have total current, so we can identify IC or not. So I have done it for you. IT is 10, mu is 0.4, so IT will be how much? IC into a square root of this, because I have removed the square, so IC will be how much? IT divided by this, so that will be 10 divided by 1 plus 0.16 divided by 4 divided by 2. This mu square is 0.4 ka square, that is how much? 0.16 divided by 2, that will become, let us say this is going to come up as 9.6225. Okay, now what is the next mu that was available? 0.8. so mu dash, let's say, is 0.8. Similarly, what would be the IT dash? So IT dash is new amplitude modulated carrier current, amplitude modulated current, so that will be how much? IC into square root of 1 plus mu dash square by 2. So IT dash is, you have IC, that is 9.62 multiplied by 1 plus 0.64. Why? 0.8 ka square is 0.64 divided by 2. That is going to come up as how much? You want, you can solve it. 9.62 into a square root of 1.32. Okay, so a square root of 1.32 multiplied by 9.62 is going to give you 11.005 ampere. So this is it. So like we have solved quite good questions that we have been asked in GATE paper for amplitude modulated signal. We'll proceed next questions in our next upcoming videos. Thank you.